Hello. So I promised that I would make this video of this Chapter 4 review worksheet for you as you're starting to study for the midterm. And so let's go ahead and get started here. It says determine whether the random variable described is discrete or continuous. So you can see I've already marked the answers on these two, but discrete is always things that are countable, and you cannot have half of a number of persons, right? So there are things that are countable. The blood alcohol level of a driver pulled over by the police in a random sobriety check. So blood level is continuous because it's measured. Anything measured is always continuous. So now we have something discrete. It's the number of broken eggs in a randomly selected carton of 1 dozen eggs. So there's 12 to choose from. The probability distribution of X is given, and I've got part of it filled out. And it says calculate the probability of 4, which when X is equal to 4. So the probability that we get exactly 4 broken eggs. Well, if we look at the probability distribution, we know that they have to add up to be 1, and they all have to be positive or less than or equal to 1. And these right here add up to be 0.97. And so that makes 0.03 the probability of getting exactly 4 broken eggs. It says explain why this probability distribution is discrete. Because broken eggs are countable. C says interpret P of 1. And that is the probability of getting exactly 1 broken egg in a carton of 12 eggs. Find the probability that at least 1 egg is broken. So at least 1 looks like this. It's 1 or more. So we would add up 0.13 plus 0.1 plus 0.06 plus 0.03, or we could just subtract the only one that we're not including, which is 0. So we could say 1 minus the probability of 0, which is 1 minus 0.68, which is 0.32. That's probably the easiest. Find the probability of X being less than 2. So that means we have the outcomes of 0 and 1. So we can find the probability of 0 plus the probability of 1, which is 0.68 plus 0.13, which gives us 0.81. Compute the mean of the distribution and the standard deviation and then interpret them. So this is going to be kind of one thing together. And because we have a discrete probability distribution, we have to use our weighted average in Desmos. So we're going to go ahead and go to our Desmos screen here. And then we're going to look at the one that's the weighted average. And so I'm just going to edit this data here. And we only have 5, so 0, 1, 2, 3, and 4. And then this is 0.68. 0.13. Okay. And then it already uses X1 and Y1. So we've got 0.63 is the mean right here. And then the standard deviation, we have to use the one down here for the weighted average. So it's using the weighted mean in here. So 1.07. So the mean for part F, I'll show you my paper momentarily, is 0.63, and the standard deviation is 1.07. It said 1 decimal place, so 1.1. This could just be 0.6. So on average, we would expect 0.6 broken eggs out of a dozen, give or take 1.1 eggs. So you're always going to say on average, and then we would expect, and then whatever your description is, putting in the mean. And then when it's a discrete probability distribution, always say out of how many you're talking. So we're saying out of a dozen. And then give or take explains the standard deviation and then what that standard deviation is with the units. Okay. So we're going to look at number 3. We're not going to complete all of it because not all of it is relevant for our class. But so it says you bet $1 on the 31-34 line. And you can see that here where I'm coloring in purple, it includes these 6 outcomes. And it says the casino payout for a line bet is stated as 5-1, which means for $1 bet, you will receive your $1 back plus 5 from the casino. So that there's 2 options in words. We could win or lose. And the profit if we win is $5 because we're also getting our $1 back. And then if we lose, it's just the $1 bet. So it's a -1. The probability that we win is going to be the 6 ways to win out of 38 because we have the 36 outcomes plus 0 and double 0 makes 38. And if there's 6 ways to win, that means we have 38 minus 6 ways to lose, which would be 32 out of 38. Find the expected value of the profit. That is the weighted average in Desmos, the weighted mean. So I'm going to go back to our Desmos momentarily. And I'm going to delete those. And then I'm going to put 32 divided by 38. And then that's 6 divided by 38. And this is 5. And this is a -1. And then there is our expected. We're expected to lose. That's why it says -5 cents. So money is always, it says give 4 decimal places, but it's really 5.26 cents, right? 0.0526. So it says, is this a fair game? No, a fair game is only fair if the expected value is equal to 0. So no, because it is not 0. We do not talk about the house edge in our class. But we do say, if you place a $1 bet on the 31-34 line 50 times, what is your expected profit? Well, 50 times our expected loss, which would be about $2.50 loss. And then F says, if you place a $25 bet on the 31-34 line, what is your expected profit? So $25 times that same expected loss, let's go back and look at that. Desmos. Down here we can do 25 times. So it would be $1, a loss of $1.32 rounded. And then the one from above was the $2. It was $2.63 loss if we do it appropriately here. So I'll show you the change. So this would have been a loss of $2.63 because I multiplied the exact values together, and a loss of $1.32. So only take what you're willing to lose at the casino. That's how that goes. Okay. So 4 says, determine whether or not the following probability experiments qualify as a binomial experiment. For those that are binomial experiments, identify and or explain N as F, X, P, and Q. For those that are not binomial experiments, explain why not. So it says you ask 10 of your friends standing in a group one by one whether each of them will come to your backyard party. Before you talk to them, you guess the probability they will say yes is about 85%. Okay. So our first thing is a fixed number of N, which is yes, there's 10 friends we're going to ask. And there are 2 outcomes, probability of success would be the probability of a yes would be an outcome. And then Q is going to be the probability of failure, which is the probability of a no answer. And are they independent is the next question we have to ask. And I would say no, only because if you're asking everybody in a group, they're probably not independent answers because one friend's answer might depend on the other. So no, because you are asking in a group. If you weren't asking in a group and they were independent answers, I would say yes. So B says 13% of the US population has diabetes, according to the CDC. The hospital sees a random group of 100 non-related emergency room patients and is interested in the number that have diabetes. So let's try this again. So 1 says fixed number of N would be yes, the 100 non-related patients. 2 is the outcomes of success and failure. So success would be has diabetes for the sake of this experiment. Failure would be no diabetes. Three is probability of success is 0.13, and Q is 1 minus P, or the same as the probability of failure, which is 1 minus 0.13, which is 0.87. They are independent, independent outcomes. And X can be anywhere from 0 patients that had diabetes all the way up through all 100. So that's always N. Okay. So now we're going to dive into actually finding these probabilities of these binomial outcomes. So number 5 says, determine the indicated probability for a binomial experiment with a given number of trials N and the given probability of success P. State the Desmos entry and give 4 decimal places. So these are binomial experiments. So we know that it's going to be the binomial distribution. And we're going to put in N for 12 and the success is 0.9. And then we are going to hit the cumulative box because it's a greater than or equal to, and it's greater than or equal to 10. So that means the minimum is going to be starting at 10 and the max is going to go through n, which is 12. And so that probability we're going to find in Desmos. And I'm going to use another one here. So I'm going to go ahead and type binomial list, and it's 12 and 0.9. And we said cumulative, and the min was 10, and the max was 12. And so that probability is 0.8891. Right here, 0.8891. Now the next one is set up the same, but this time we just want to know the probability between 9 and 12, and we're including them with the less than or equal to on both. So it's going to be very similar, except for my min is going to be 9, and my max is going to be 12. And so let's see what that says. So we're going to just go to 1. And that's 0.9744 rounded appropriately. 0.9744. So the binomial dist. Question number 6. It says, explain which graph is appropriate for binomial distribution. So discussions that we've had in class, we know that with the normal curve, that the center is usually where the mean is, because that's where the majority of the data falls. And so we would want to find out what is the mean for this particular situation. So this particular situation would be n times p because it's binomial, which means it's 90 times 0.4 or 36. And this graph here, this one, it looks like the center of the mean is at about maybe 53 or so. This one definitely looks like it's at 36. So that's why it's graph A. And the last question on the back page, question number 7, is all surrounding the, says according to the CDC, 7.5% of children aged 6 to 17 have used prescription medication during the past 6 months. Medical A researcher randomly selects 100 children between 6 to 17 years. Find the following. So N is the 100 children. P is 0.075 that they have used medication, prescription medication in the past 6 months. The mean is N times P. So 100 times 0.075 is 7.5. And the sigma is the square root of N times P times Q, which is 100 times 0.075, and Q is 1 minus 0.075. So let's just go to Desmos to check both of those. So 100 times 0.075, and then this square root of 100, 100 times 0.075 times 1 minus 0.075. And so the standard deviation is 2.63. So part B says interpret the mean and standard deviation in the context of the situation. So we always say out of when it's a binomial. So we have to say out of whatever n. So out of 100 children, we would expect 7.5 of them to have used prescription medication in the past 6 months. So out of 100 children, we would expect 7.5 of them to have used prescription medication in the past 6 months, give or take 2.63 children. Describe P of 9 in words using the context of the situation. So P of 9 means the probability that exactly 9 children out of 100 have used prescription medication in the past 6 months. D says, find the probability that at least 3 of them have used prescription drugs in the past 6 months. So at least 3 means the probability that at least, so greater than or equal to 3. And so we're using a binomial where n is 100, the probability of success is 0.075. We're going to use the cumulative box because it's a greater than or equal to, and that means we want everything equal to 3 or more up to 100. So our min is 3 and our max is 100. And so we're going to go to Desmos here, and I'm just going to go up and rearrange this and change that to be 100. And this is going to be 0.075. And then it was 3 children all the way through 100. And so it's very likely 0.9829 rounded appropriately. So the next one says, find the probability that between 4 and 11 inclusive of them have used prescription drugs in the past 6 months. So inclusive means we're including 4 and 11. So we want to find the probability that X is between 4 and 11. So X is greater than or equal to 4, but less than or equal to 11. So we're still going to be cumulative. And this time our min is 4 and our max is 11. So let's just go back there and change up our Desmos to be 4 and 11. And that probability is 0.8761. 0.8761. And then F says find the probability that 11 of the children in the sample have used prescription drugs in the past 6 months. Would this be unusual? So exactly 11. So the probability that X equals exactly 11. So we're not using the cumulative. It's not cumulative. So let's just show you what this looks like. So this means we're just going to go to Desmos and unclick the cumulative. And it's going to show us, you can see all of them over here. And then if we hit our magnifying glass, it'll actually look more appropriate, like the shape. And we want to find exactly 11. So 11 is going to be here somewhere. So I'm just going to, that's number 10. There's 11. So 11 is 0.058. So 0.058. Now we have to have that conversation of, is it unusual? That seems pretty small. But remember, back in the lessons in class, that it's only unusual if it's less than 0.05. But because it's still bigger than 5%, it's not considered unusual. And we're going to build on that unusualness as we move on to chapters 5, 6, and 7 coming up here. So that should have been a good review of chapter 4. Let me know if you have any questions regarding that. Bye.